Look at that. It definitely a lot of strength was used, right? Because it didn't want to melt, then you probably just kept pushing it harder to the point where the board itself is damaged. Hello friends, welcome back to the bench. Today we have an ECM for Tyler from New Hampshire for IC 608 resoldering. Nothing new. Tyler is supposedly suffering from misfires on one of the cylinders, or maybe more than one. And our solution is to remove the solder from IC 608 and replace it with new solder, the leaded solder. So let's get it done. I finally got my Polish flag behind me, and this time the eagle is facing the right way. One person noticed that in my previous setup that the eagle was looking to his left and he should be looking to his right. That is something that you learn at school, like a primary school, I think, in like 3rd grade or something like that, where you also learn some other stuff, patriotic stuff. But one of the things that you learn is that the eagle always looks to the right, for whatever reason. So I corrected that. I didn't think anyone would notice. Actually, my roommate back in Wyoming noticed that immediately. But then I figured no way anyone's gonna even know on just by watching the video. And sometimes when you record, you know, your image is it's mirrored. Here, the recording is a mirror image, so that would also explain why the eagle is not looking in the right direction. But in my case, I just put the flag the wrong way, and I never corrected it, so I figured, who cares? I certainly don't. But now, as some of you know, I'm in Georgia. That's where I moved my shop. So I'm in a much warmer place. I left that god-forsaken mountain town. I mean, the town is okay, but the problems, especially problems with post office, that was a big hurdle. And I really don't appreciate winters. I don't like being cold. And in that town, you really had to get used to being cold. Some more light, and today I will use a more professional hodder station. Oh, my scope is too wide. Oh, what happened here? Okay, this is not gonna be a quick job, I guess. take a look at this. That's not good. We're gonna have to retrace it. What happened here? It's right by... Oh, come on. I was working on a much bigger device. So, oops. So I had to lift my scope. Take a look at this. Yeah, there was a prior repair attempt. And the trace is broken. Okay, so this is kind of a worst thing that can happen. You see that? So the trace is broken. Let's see. What is this? Trace is definitely broken. Let's get better tweezers. I don't require anyone to mention whether there was a prior repair or not, but it is kind of a good information to have. So I know what I'm getting into before I start. And as I said, I always encourage everybody to try the repair themselves, because it's not that difficult. But you can actually see it in my early videos. That, you know, or if you compare it to my latest videos and my early videos, that I gained proficiency in it, right? So yeah, it's not as easy when it's your first time, right? Okay, so the chip is on right way, and it looks good. I think we need to replace it, because it looks like Tyler or whoever worked on it just focused on this. This is cylinder 6. And indeed, this will correct the problem for a little while if you just heat it up over here. Just kind of fix this this connection over here. It does help for a little while, not for long, but it helps for a while. But as soon as the weather changes, the temperature drops, humidity rises, the problem will come back. The way I do it, the problem doesn't come back, or at least not for a year, because that's the oldest repair I've done, and so far no issues. So let's do this. We're gonna take the chip off, remove the solder, put the chip back on, and retrace cylinder 6. Probably the pin is gonna fly off like it was last time. I don't remember who it was I was fixing it for, but also there was a prior repair attempt, and this particular trace was completely detached from the board. And this is the thing. So you can see me using, or on my first videos, my old videos, I was using this soldering iron, right? It comes with the soldering iron and other station, right? The soldering iron is this kind. Alright, so these are the tips for it. Alright, this one's a little bit rusty now. And these are really cheap, really affordable. You actually get the pack of these with every soldering iron that you buy. So I have tons of these. So I use this iron for pretty much like dirty work, right? If I just have to melt some plastic or burn some wood, that kind of stuff. But the problem with this iron is that it doesn't have enough thermal mass to maintain temperature, and the thermal feedback is here inside here, not in the tip. So you basically lose a lot of temperature as soon as you touch something. You lose that temperature. Then it takes a little while for the iron to reheat it, so you get stable temperature on the tip. So basically with this tool you don't get stable temperature. And what do you do then? Naturally, you just increase the temperature on the iron, on the controller. And as you do so, the temperature is too high, but the tip is still losing too much temperature. And then you touch the pin over here until it melts. It doesn't want to melt, so you increase temperature even further, and you basically heat up the pin, heat up the trace too much, and it just detaches from the board. It's very common, so I'm almost sure that this is the kind of iron that was used to perform this repair. As you've seen on my old videos, I have been using that iron for quite a few repairs, so you definitely can do it with this iron. But I did have one failure. I had to redo one job because I messed up soldering. And actually, I believe I was already using the better one, this iron. So this one is different. As you can see, it's a lot smaller, right? Look at the size of this tip and this tip, right? Actually, let's look at it under the scope, right? This is the big one, and this is the one that I use, right? A lot smaller, but the small one is built differently, and it may not have as much thermal mass as this one, but it keeps the temperature stable. So on the soldering iron, you see how much power is being pushed to the handle, right? So you see, as you touch something, right, the power on the iron starts rising, and it drops as basically it keeps the tip at a stable temperature, not high temperature, stable temperature, and that's what you need. To do it with this iron and do it well, you also need to leverage some hot air. So as you're working with this, you have to blow some hot air on it to keep the temperature stable, to keep the temperature high enough. Otherwise, the temperature drops really quickly. And this board is pretty thick. It's designed to kind of sink all that heat into it. So it's really hard. It's really hard to do it with improper tools. So, to whoever performed this repair before me, don't feel bad, because this is how I messed it up. Well, I didn't mess up this bad, but I messed it up the first time I did it, so no worries. It looks a lot easier on YouTube than it actually is. Okay, so my setting will be 390 at 50 liters per minute. I was actually contemplating using my old iron, so the other one that I got, the first one, I paid $50 for it. $50 for both holder station and the soldering iron handle with tips. It's great price, but if you have cheap tools, you have to have a lot of skill. If you have expensive tools, you don't need that much skill. If that makes sense. Okay, let's actually move it a little bit closer here, like so. So let's remove it first, and then figure out what to do with that trace. Okay. The same with other station, other station. So as you can see, this one is a lot more sophisticated. I can program the temperatures and airflow. The airflow is actually described in liters per minute, so I can give you the the number that you can replicate with your device. On the old device, I couldn't do that because it just goes from from 1 to 7 or 8. We don't know what that means. And the temperature is actually not very stable. I was using 370 on the old one, and on this one, as you can see, I'm using 390 because 370 is not big enough, not hot enough. All right, now I forgot the flux. Where's the good flux? Where's the good flux? This also could have happened, now thinking about it, this could have happened on this trace issue over here because the flux was not used to desolder it, or to resolder it. But even if you used good flux, I don't think you would be able to just resolder it using that factory flux. There's just something about using factory solder. There's just something about the solder from these years that, I don't know, cause issues. And it doesn't want to flow. It's not great. That's why only RMA flux works with this. Look at that. Right? With regular flux, this would not be happening. Right? It would be very hard to clean it. Also, let's get some fume extraction. 60 is fine. Also, as I already mentioned, the iron tip is pretty important for getting this, getting the old solder off, so for cleaning. Because as soon as that crappy iron tip touches the board, it loses the temperature, right? And as it does, your wick is just gonna catch, and I don't know, the cleaning will not look good. This is pretty much as good as it gets. Now let's clean the surface and see what kind of damage we have to the trace. We will have to retrace it, but good news is that it's a control pin. It's not a power pin. which means this is where the control signal comes from the controller. So we don't need a lot of current on it. Now let's see. Okay, it looks like the pad is actually holding. It's only the trace that was damaged. So that definitely seems like the iron tip was just not capable of holding or maintaining the temperature to melt the solder. In the previous one, I had this issue. This whole pad just flew off as soon as I put iron on it when I was cleaning it. This one is holding, but look, look at that. It definitely a lot of strength was used, right? Because it didn't want to melt, then you probably just kept pushing it harder to the point where the board itself is damaged. And if I had to guess, this was a chisel tip. Why do I think it was a chisel tip? You can kind of see why it broke the trace. So here, let's see. So it was facing this direction. Let's see. This one is completely damaged. So it was facing this direction, right? So the very tip of it was touching the trace over here, right? And it was laying flat like this. That's why it cut through the trace. And it even made a little bit of damage over here. There's a big hole over here. So this is actually not a significant damage. It's not ideal, but it's not too bad. We can definitely fix that. It just takes a little bit longer. And the worst part is that the price is the same. Whether you have damage to the traces or like the pods are completely missing, it's the same price as if I just quickly resolder your IC 608. Well, that's the way she goes. That's the way she goes. Not everything can be easy, gentlemen. Check. Actually, see, I this up. That's good. I'll just want to here. I can clean. It's very important to take all the solder, all the old solder off. You don't want to leave any of it. there. Now let's clean the tip. This one's pretty much almost done. I have another one. I mean, it doesn't look too good, but it doesn't look too bad either. But, you know, it kind of, you know, I've been using it for a while now. I have a brand new one. I always get the brand new one before I need it. And I always have two of everything. So whatever happens, the work can continue. And stuff breaks. Actually, my bench power supply broke. Luckily, I have two more that I can work on. So that's the redundancy. Too much, but enough, so I don't have to have too much on the board. No, that is good enough. Okay, now the chip is ready. And let's clean the top of the chip, just so we can see where the pin number 1 is. It's not like it's gonna break anything, but it always terrifies me when I see that alcohol just basically boiling off underneath the tape. It has never been a problem, but you know, it's never a problem until it is. And it can be healthy. Also, the important part of it is that the captain tape needs to sit flat on the board, so the header goes above the tape, not underneath, because then it kind of defeats the purpose of that tape even being there. It might not be terribly necessary to even put it on. I always do, because I work on customer stuff. Right? When I do it for myself, I sometimes just take shortcuts, and I don't know, you know how it is. But when I do it for the customer, then I want to take every precaution, basically just do my due diligence. No shortcuts, because that ain't what you're paying for. Okay. Now generous amount of flex. It's another clean tip. No, it's all good. So you don't need to here. It's just it's just a price tag attached. Okay. That coffee was not a good idea. My hands are shaky. Not good. Not good, gentlemen. Shaky hands in this business pretty much means you're out of the business. I can see. It's always sticky. Always sticky. Okay. Okay. Definitely some of these are my tools. Let's check the alignments. This is good. This is good. Okay. Here's your two sides of the okay. Nice. Okay. The worst part, watch nuggets before we do the worst part. Let's replace the dip. And this one. Let's get some flux. Let's go to 273. See? This side's hot. Now. Alright, this was perfect on the first try. Oftentimes, now I would correct like 1, 2, maybe 3 pins that didn't solder correctly. This one is perfect on the first try, so at least that went well. Now, retracing. To retrace, let's grab this. So this is regular speaker wire. No, is it speak? No, regular. What do you call it? Electrical wire. And I'm gonna grab one of the tiny wires. Yeah. There. Then, the flux. Okay, that's enough. Okay. So I wanted to roughly go as the trace goes. Alright. It's a bit much solder over here, but it's better to have a tiny bit too much than tiny bit too little. No, that's not like, yeah? Okay. That looks good. So, yeah. First job on the new place, and of course it's gonna be retracing. Because why not? But now I have much better equipment, so I shouldn't be complaining. On the other hand, on polish, when complaining is what we do. Even when things are perfect, we complain because they could always be perfecter, right? Okay, well, now let's give it some more cleaning, put some UV mask on it, and call it done. What are you doing, man? You got it. Let's see, the brush. Okay, now it's not sticky. And what's your shine? There's no flags left. Pretty mask behind left. Oh, it's sticky, that's fine. And I will say, oh, that's fine. Okay. And we'll not too much. And also a little flex on the mask. I have to make some big shots soon. What does it mean? That's just a bucket. Close your eyes, boys. Let's keep it like this for a few minutes and that will get the job done. Alright, so that was retracing, which happens. Actually, it happens a lot. If you try that and this is your result, well, either try again or do this. If you're not comfortable retracing, send it over to me. Let's see. Looks like my camera stopped recording. That's too bad. Okay, we lost one camera. I don't know when, but it stopped recording. That is fine. That is quite okay. We'll see when. Okay, that looks all solidified. So Thank you very much, Tyler, for your business. As you can see, everything is repairable. Even if you have awful tools, it's all repairable. Or at least this is. Thank you guys very much for watching. And I shall see you in the next one. As I have one more in queue and one more coming today. So it's raining ECMs, which is awesome. Thank you guys. See you in the next one.
Black Horse Repairs, subscribe.